So Izzy and Ellie, so I'm going to go over your quizzes onto your test in chapter 6. Your test number 4, we're going to start with quiz number 10, and then we're going to go over some of the reading quizzes too and see if you can remember these things. So go ahead and go through them, and then we can check them over. So the questions are true or false. Quiz 10. The type of energy associated with motion is called motive energy. Have you ever heard of motive energy? No. What do you call the energy of motion? You call it kinetic energy, right? You should know that one. Number 2, the type of energy associated with the position of an object relative to the forces upon it is known as potential energy. Yes, potential energy has to do with position, right? Or stored. Let's see. So that one's true. Number 3, in thermodynamics, the portion of the universe of the sample of matter being studied is referred to as the system. Yeah, the portion that you're studying is the system. And basically the everything else is the surroundings, right? So number 4, according to the first law of thermodynamics, this is not the second law, the first law of thermodynamics, the change in internal energy is the sum of heat and force. So no, the sum is always of everything is either heat or work, not force. So the sum, they have force there, it's false and it's work. The sum of everything, the sum of all internal energy is heat and work. So it's false and you plug in work. Number 5, the SI unit, the Scientific International Unit of Work and Energy is what? You have all those questions there. What is the SI unit? I hope you know that. It's always the joule. We're going to be dealing in joules. Number 6, the thermodynamic function denoted by the symbol H, which takes into account internal energy, E and volume and pressure, is which one of those? We've been talking about that a lot. So I would say B, enthalpy, right? So basically enthalpy or enthalpy. That's going to be the name. And that means, all it means is it's internal heat is what it is that takes in volume and pressure. So number 7, a chemical reaction that can be summarized by the formula of reactants plus heat equal products is what kind? Okay, so when it's reactants plus heat, it's absorbing heat from something, so you'll have an endothermic reaction. Exo means the heat's exiting. At this point, you have the reactants pulling in heat. So if you're pulling in heat, you're making things colder on the other side, right? So you're pulling in heat, and this would be endothermic. So number 7 would be endothermic, which would be what? A, I think it is on there. Number 8, a chemical reaction that can be summarized by a formula. Reactants, with the arrow there you see, equal products plus heat. Which one is that? That's going to be just the opposite as the one we did before. So you have the reactants that are reacting, and then they're producing products, plus they're going to release heat, exit heat. So you're going to have exothermic. So on to, let's see, number 9. So that would be, number 8 would be B, exothermic. The heat required to raise a temperature of 1 unit of mass of substance by a unit of temperature is the what of the substance? What do you call that? So they have a specific name for that, specific heat, right? So anyway, what is that? A specific heat, D. So number 10, the device in which energy changes during a chemical reaction may be measured by what device there? So I hope you look at it. It's a calorie meter, right? Calorie meters are measuring heat. So, and what's that? Number C. So that's all of that quiz. So hopefully you got a good grade on that quiz. Let's go on to your reading quizzes. And I will be giving you the reading quizzes, too. So you can just write them down and be graded by your mom, so. Lesson 45, a reading quiz as number F. So number F quiz. What branch of chemistry studies energy changes in chemical reactions? We're just talking this a whole chapter about this. What are we talking about? Chemical thermodynamics. And this is the branch of chemistry that we're going to be talking about, is thermodynamics, chemical thermodynamics. Number 2, what type of energy is associated with motion? We already did that question, right? Kinetic energy. True or false? The portion of the universe being studied is the surroundings. No, the portion of the universe that you're studying is going to be the system. The surroundings are everything else. So that'd be false. Number 4, internal energy is a what function? Well, internal energy is a state function. That's the state. It has a relatively state, so that one's a little bit, maybe you wouldn't get that answer. So a lot of people get that one wrong. I did. So number 5, what law equates internal energy to heat and work? So when you're talking about internal energy, there's only a couple laws that we've been studying. Number 1 is the first law of thermodynamics, and number 2 is the second law of thermodynamics. The second law has to do with entropy, which we learned before. It has to do with everything getting disorderly. So, but the first law has to do with the conservation of energy, or of internal energy. So what law equates internal energy and heat to work? The first law of thermodynamics. You got 50-50 chance there. We're talking about laws, huh? So let's go on to your next reading quiz, which is lesson 51. So number 1, it's reading quiz G. The term entropy refers to the measure of what aspect of a system? Entropy. What's entropy measuring? Disorder or randomness, right? Everything's getting more disorderly, going from order to disorder. So disorder. Number 2, what symbol is used for entropy? It's the symbol S, like Sam, right? So S is going to be, and I don't know why they picked that S, but that S is what they use as a symbol for entropy. So what scientific law says the universe's entropy is always increasing? So what law? We only had 2 laws, remember? So what law talks about the universe, the disorder of the universe is always happening? Things are going from order to disorder in the universe. Basically things are deteriorating in the universe, really? That's the second law of thermodynamics. Pretty important because that affects everything in our universe. So, and as God says, like sin has corrupted everything, and everything is getting worse, more disorderly, and people, we get old and die. Everything gets old because of that, because of what God has put forth with the law of second law of thermodynamics. There's only 2 laws that really we're talking about, is the first and second so far. So you got a 50-50 chance again. It's the second law. Considering only the system, would the evaporation of water result in a positive or negative change in entropy? So entropy means it gets more disorderly, right? So if you have water evaporating, it's going from a liquid, which is very orderly, you got the liquid, and then it's going to start shooting out molecules in all directions, so it's going from order to disorder. So when it's going to get more disorderly, it's going to be positive. So it's going to be a positive entropy. So is it negative or positive? You put positive. True or false? Reactions that decrease the entropy of a system are almost always spontaneous. So no, when reactions that increase entropy, So whenever increased entropy is happening, that's just natural because everything is getting worse, everything is getting more disorderly, So reactions that increase or that decrease the entropy are going to be building up. So this question has to be false because spontaneous things happen. Spontaneously things happen, and that's things are going from order to disorder. So a decrease in entropy is always spontaneous. That just happens naturally, just the way God made us, the universe. Everything is going from order to disorder. So increasing in entropy, not decreasing. So that would be false. So those are the quizzes and only over chapter 6. I think we could start going over some of the tests, and I'm just going to skip the questions that you have to do a lot of mathematical figuring because we'll have to do that together, or you do it and then we'll check that over. And those really are important too, and there's only a few of them, but most of them are multiple choices and such. So let's go on to your test 4. So some of these questions. So we're going number 1. Which contains more energy? 25 grams of boiling water at 100 degrees or 25 grams of steam at 100 degrees? Well, that's a good question because if you have 5 degrees boiling water, it hasn't gone through its vaporization energy yet. And steam, if you get burned by steam, it's going to be very, very hot because basically as it turns to a gas, it gains more energy. So what that's saying, basically it says, one of those says steam is hotter with the heat of vaporization. Yes, steam is going to be hotter than water. So if being burned by steam is going to be a worse situation than being burned by water. Okay, so steam is hotter with the heat of vaporization. I think it's B. Number 2, what best describes the fact the change in internal energy, and that's at delta E there, equals the difference of final value and initial value. So basically, you're going to say final value and initial value, that you have to have a foundation, in that point. So it's basically saying internal energy equals the difference of final value and the initial value. It looks like it's a state function. So I'm not too sure of that one. So I'm going to let you look it up. So on to number 3. Randomness of substance is what? You should get that one. Randomness or disorder is going to be what of those things? And I see entropy. Entropy is randomness or disorder. D. Number 4, internal energy of a system and the product of pressure and volume. Which one is that? Remember, if you just have energy, it's going to be E, right? Just an E. But if you have a letter H, it's going to be which one? It's going to include pressure and volume, and it's going to be called enthalpy. Enthalpy. I'm trying to say it so you can see, which would be number A. So internal energy and the product and pressure is always enthalpy. Water, number 5, water at 0 degrees changes to ice at 0 degrees. So what's going to happen here? You are taking the liquid to a solid. So you're taking the liquid to a solid. It's going to become disorder to order, right? So if you're having disorder to order, which one of those could it be? From disorder to order, from liquid to solid. So from liquid to solid, what's going to happen? Well, from liquid, if you go from a liquid state to a solid state, you're going to release heat, right? Because you're getting colder, so heat's going to be released. So if that's one of the questions, heat's released. So anyway, number 6. Mixture warms slightly after a reaction. So if a mixture warms slightly, after a reaction, that's going to mean what? So you have the products. The products are on the right side, and you have the products and you have the reactants. So which one's going to be less? Which one's going to exit things? So you're going to basically know that you're going to describe the products are going to be less because they're exiting the heat. So products are going to be less than the reactants. That means the heat is getting warmer, so it's exiting. Okay, I think that's number A. So number 7, which best describes the flow of heat? How does heat flow? From hotter temperatures to lower temperatures. From hot to cold, right? B, you should know that one. Number 8, the sample burned in a pressure container, volume constant, I hope I got this right, 100 joules heat released. Which best describes this experiment? So the sample was burned in a pressure cooker, I guess it's a pressure cooker, or a container with a volume constant as 100 joules of heat released. Which best describes this experiment? Okay, so which one? So you have heat released. And if the internal energy is released, what happens? The internal energy is the enthalpy. So is that going to be positive or negative? Well, if you have exit, it's exiting, it's going to be negative because you're getting rid of it, right? So it's going to be A. The internal energy is going to be negative because it's being released. If it's released, it's going away, making it negative, more negative number. So the internal energy released is negative. So number 9, how is energy defined? I hope you know that. Energy is what? The ability to do work, right? So number 10, a device used to measure heat flow. How about a calorimeter? It measures heat flow. Number 11, which of the following changes would not be expected to increase entropy? So that increase disorder. So all of those things, you have a list of them there, and I don't have the list there, but I do know that all of those things will decrease disorder, except for the very last one, which is very unusual. You have a molten lava turning to solid. So you have a liquid turning to solid would be the opposite. So it would be the only one that wouldn't increase the entropy because you have, it's going from basically disorder to order. So that's the one that would be the last one. So the change in a system's internal energy is the sum of the heat added to the system, and the work done on the system is the blank law of thermodynamics. Which law is there? There's only 2, first and second. So which one would you put? Well, the change in systems in internal energy. We're not talking about disorder anymore, which is the second law. So it's not going to be the second law. So the change in systems in internal energy is the sum of the heat added to the system and the work done on the system, which is the first law of thermodynamics. Number 13, the thermodynamic state of a substance in its normal physical state at 1 atmosphere and 298 kelvins is the what? That's their standard. So it's going to be the substance standard state, right? Those are kind of the standard state is a little bit iffy, a little hard for me to explain. So let's go on to number 14. Chemical and physical changes that release heat are known as what? What are they when they release heat? They're exiting heat. They're called exothermic, exiting heat. Number 15. When discussing thermodynamic concepts, the portion of the universe or sample of matter under study is called what? The system, right? The system is what we're studying, and everything else is called the surroundings. You learned that right at the beginning of the chapter. So number 17, The SI unit of energy, heat or work, is measured in what? Joules, right? Joules. Number 18. The field of chemistry that deals with the energy changes in chemical reaction is called chemical what? It's the title of our chapter, Chemical Thermodynamics. Number 19. Chemical reactions and physical changes that absorb heat are called what? When they absorb heat and make things colder, they're called endothermic. They're absorbing. Now, when you're exit heat, you're going to be exothermic. When you're absorbing heat, you're going to be endothermic. So that answer would be endothermic. Number 20, true, false. These are true, false ones. I'm going through the easy ones first, then we'll get to the, when I say easy ones, well, we'll get to the longer problems and mathematical problems later. So, number 20, the type of energy associated with positive relative to a force is called what energy? The type of energy associated with position. I said positive, like what is this? Position is relative to what force? Is it relative to kinetic energy? That's the question. It's kinetic energy? No. Kinetic energy has to do with motion, not through position. So that is false. It's going to be potential energy. So instead of kinetic energy, it's going to be potential energy. Number 21, an endothermic reaction is characterized by a negative change in enthalpy. So when we have endothermic reaction, endo is going to be basically taking in. So if you're taking something in, it's going to be positive. You're not going to exit things. If you exit something, it's going to be negative because you're getting rid of it. You're getting rid of energy, so it's going to become more negative. So that's false. So an endothermic reaction is characterized by positive change in enthalpy, right? That means the reactant plus energy equals the product, okay? So number 22, according to the second law of thermodynamics, the entropy of the universe is decreasing. No. The entropy of the universe is getting more disorderly. Entropy means more disorderly, right? So the entropy of the universe is increasing. It's getting more disorderly. So that's going to be false. And let's see. The entropy of formation, let's see, where was I? No. Which question was that? Okay, the enthalpy. Okay, the enthalpy of formation for any element in its standard state is negative. I kind of lost my place there. Oh, according to, that was number 22. According to the second law of thermodynamics, the entropy of the universe is decreasing. It's false. It's increasing. So kind of lost my place. Number 23. The enthalpy, that's that internal heat of formation for any element in its standard state is negative. The standard state would just be the state that it happens, that element, if it's a standard state, and it would be equal. Everything would be equal. So the number could not be negative and the number could not be positive in the standard state. It would have to be, the number would have to be 0. So basically, instead of being negative or positive, the number would have to be 0, equal. Standard state means it's just in the regular state, and that's the state it's saying, and it's equilibrium, which means it's not going to change unless something's put on it, right? So that would be a 0 state. When a cup of water evaporates into water vapor, the entropy change of the system is positive. So when we have, okay, are we going from order to disorder? So we have water, which is more orderly because you have water. It's all the atoms are more orderly there, and it's popping out to the vapor disorderly. So you're going from order to disorder. So you're going to have more entropy. So when a cup of water evaporates into water vapor, the entropy is going to be more positive. So that's going to be true. So number 24 would be true. Number 25, at a constant pressure, enthalpy changes. At a constant pressure, enthalpy changes equals heat. So, so at a constant pressure, enthalpy changes. If an enthalpy changes, if you're changing the internal heat, it equals heat. Yeah, that's what it is, internal heat. So I guess that one's just true. So number 26. In an experiment, the temperature of a reaction is measured at 24.6 degrees. After the experiment, the temperature of the product is measured at 17.3 degrees. So this reaction is endothermic. Okay, we have to see if it gets colder or hotter. So we go from, if we're going from 24 degrees centigrade and then we're going to 17 degrees centigrade, we're getting colder. So which one of them gets colder? Which reaction? Is it exothermic or endothermic? Well, exit means it gets hotter because it's exiting heat, right? So you're taking in heat in the midst of this is going to be endothermic, and it'll make it colder, like a cold pack. You know, when you take a cold pack and you put it together, and it gets colder because it's endothermic. So the reaction is endothermic. I guess that's true, right? So I'm going to go on for a little bit more. Where are we at? Number 27. The heat per unit mass required to vaporize a substance. These are matching, so you can look on your sheet. And so I'm just going over them because I don't have your sheet. But the heat per unit mass required to vaporize a substance at its normal boiling point. So this heat, the heat to vaporize, is going to be called the heat of vaporization. That's pretty easy. So I hope you got that right. Number 27, the heat of vaporization. Number 28, the total amount of heat liberated or absorbed because of a chemical reaction. The total amount of heat is going to be the heat of the reaction, right? That's another one, the total heat of the reaction. So the total amount of heat is going to be the heat of the reaction. Number 29. The heat per unit mass required to melt a substance at its normal melting point. So what do you call melting? Melting that heat. Heat of fusion. Remember, fusion is melting. So heat of melting, the heat of fusion. Number 30. The amount of heat required to cause a unit rise in temperature of a unit of mass substance is going to be the specific heat. 1 unit of mass, 1 unit of rise in temperature, and the amount of heat is all different from every different compound. Is going to be different for that heat, for that breaking up of that compound. And they call that specific heat. And that's those tables that you found in your book that said the specific heat of certain compounds, right? So let's see, number 30. These next one, number 31 and number 32. Number 33, I'm going to have to explain for you on paper. So you can kind of skip those right now and we'll go over on paper in those. And number 34 is a harder, I had a hard time with number 34. And number 35, number 36, we'll do those and I'll show you how to do them on a different video because that'll take a little while, and let's just go on. So skip those for now, number 36. Let's just go to the essay question. This will be the last one on this video. And the essay question is so easy. It's what I've been talking about the whole time. And so the essay says, many evolutionists, which we don't believe in, believe that the large complex molecules of protein and DNA, those are the big molecules, found in living cells were originally formed as smaller little molecules, and they just started building up into bigger molecules, right? And they spontaneously joined via endothermic processes. Endothermic processes don't happen on their own, and never does it go from disorder, something that's disorderly, to orderly. So what do they want? This presumed process is often called chemical evolution, right? That's what your question says. It says, evaluate chemical evolution in the light of entropy and chemical spontaneity. So that's your question. So I kind of told you what the answer is going to be. So the reaction building up molecules from simple to complex decreases entropy, right? So it's a decrease of entropy. That means entropy, it's a decrease in entropy. That means it's opposite from what naturally happens, right? So a decrease in entropy cannot happen spontaneously. This would be non-spontaneous. And what does non-spontaneous mean? It means that somebody has to help it, right? So basically you need to put a reaction building up molecules from simple to complex would decrease the entropy, which is not naturally and not spontaneously. A decrease of entropy cannot happen spontaneously. It would be non-spontaneous, meaning it would only be possible by a creator. So evolution is disproved by, the second law of thermodynamics, which says that everything is going from, in the universe is going from order to disorder. So that would disprove. So this disproves evolution. Entropy means disorder, and a negative entropy would be disorder to order, and that would be what's described here, and that doesn't happen without somebody helping it. So I hope you got that essay question. And if you need more help, just get a hold of me and I'll help you. But that's actually a very easy question, because we know that what the process of a DNA molecule being formed from a little teeny molecule getting bigger and more complicated cannot happen in our universe.